Welcome back, everyone. In this video, we're going to be taking a look at some special pairs of angles and some things that happen when we pair up certain angles in certain kinds of diagrams. So let's just jump in right now and take a look at a couple definitions. The first one is a definition of what are called complementary angles. So complementary angles. Now, complementary angles are two angles whose measures have a sum of 90 degrees. So you can see in this picture right here, I know that if I take the measure of angle XYW right here, and I add it to the measure of angle WYZ right here, I'm going to get, well, let's check it out. The measure of angle XYW is 55. And the measure of angle WYZ is 35. So if I add those two numbers together, I get 90. So these two angles add up to 90. So therefore, angle XYW and angle WYZ are complementary. They are complementary angles. We know that because of this definition we just talked about. Supplementary angles are two angles whose measures have a sum of 180 degrees. So if I take a look at this diagram, if I take the measure of angle G and add it to the measure of angle K, what do I get? Well, angle G has a measure of 120 degrees. Angle K has a measure of 60 degrees. 120 plus 60 is 180. So angle G and angle K, they add up to 180. So therefore, angle G and angle K are supplementary angles. Supplementary angles. So complementary and supplementary. Really the big challenge here is remembering which one's 90 and which one's 180. Sometimes I think about complementary starting with a C, right? Starting with a C. And if I kind of took a C and wrote it more like this, I might see that it almost looks like a 90-degree angle. So complementary means 90 degrees. That's sometimes the way I think of it. Or some people have told me supplementary starts with an S, just like straight starts with an S. And a straight angle is 180, so supplementary is adding up to 180. Either way you want to remember it, just try and come up with some way to remember that complementary is 90 and supplementary is 180. Now a couple example problems. You have to find the measure of a complement and a supplement of angle T. If angle T is 40, what is the complement, or in other words, what angle would be complementary to angle T? Well, angle T has a measure of 40. A complementary angle would add up to 90. So 40 plus what equals 90? We can take 90 and subtract 40, and we can figure out that I would have to add 50 to 40 to get 90. So a complement to angle T would be 50 degrees. How about a supplement? What would a supplement be? Well, 40 plus what gives me 180. If I subtract 40 from 180, I'm going to get 140. So that supplement to angle T would have a measure of 140. Why don't you guys go ahead and try parts B and C. Let's see, what are the answers to B and C? Well, the complement of an 88-degree angle, I can just take 90 minus 88, and I would get 2 degrees. The supplement for an 88-degree angle, I would take 180 minus 88, and what I'll get is 92 degrees. Now in C, I don't throw a number at you, I just give you a value of x. So how do I find the complement of an angle whose measure I don't know? I'm just using x to represent it. Well, I do the same thing I did on these two examples. I take 90 and I subtract the measure of the angle that I'm looking at. In this case, it would just be 90 minus x. And that's what we could say for the complement of an x-degree angle. It's 90 minus x. The supplement of an x-degree angle, it's just going to be 180 minus x. So there you have example 1. Now to make it just a little bit tougher, I'm going to bring in some algebra in example 2 here. The complement of an angle is 18 more than twice the measure of the angle. Find the measure of both angles. In other words, find the measure of the angle that we're looking for and the measure of its complement. So let's use x to represent our missing angle. Well, what is the complement? That would be 90 minus x, just like we talked about up here in example 1c. That is the complement of the missing angle. So how can we set up an equation? Well, the complement is 18 more than twice the angle. So I can turn this sentence into an equation. This is something that you should have done quite a bit in Algebra 1. I'm going to take this 90 minus x and put it where it says the complement. So 90 minus x turns into an equal sign, 18 more than twice the measure. So 18 more than means I'm going to add twice the measure of the angle. That would be 2 times the measure, or 2x. So this gives me this equation, 90 minus x equals 18 plus 2x. Now I just use my algebra skills and I do whatever I need to do to solve this. So I'm going to add x to both sides, and that would give me 90 equals 18 plus 3x. Now I'm going to subtract 18 from both sides. 72 equals 3x. I'm going to divide both sides by 3, and that's going to give me 24 for the value of x. But I'm not done, because it doesn't say find the value of x. It says find the measures of both angles. So now I can say, well, the missing angle is just x, so it is 24 degrees. The complement is 90 minus x, so 90 minus 24, which should come out to be 66 degrees. All right, one other definition we need in this video. We need to talk about something called vertical angles. So vertical angles, here's the formal definition. Two angles such that the sides of one angle are opposite rays to the sides of the other angle. Well, let's think about what that would mean. If I look at angle 2 right here, the sides of angle 2 would be this ray right here and this ray right here, right? Those are the two sides of angle 2. What about angle 4? Well, its sides are this, which is an opposite ray to this guy over here, and this, which is an opposite ray to this guy right here. So we would say that angle 2 and angle 4 are vertical angles. Vertical angles. Now the way I typically think of it is, I just look for if two lines or segments make this X-type pattern. The vertical angles are across the middle of the X from one another. So you see how 2 and 4 are across from each other, from the middle of that X right there. Angles 1 and 3 are also across from each other. So I can say that angle 1 and angle 3 are vertical angles. Now, one of the most important things to remember about vertical angles is that vertical angles are always congruent to one another. Vertical angles are always congruent to one another. And we're going to go ahead and prove that right here in example 3. Prove that if angles 1 and 2 are vertical angles here, and you'll notice I had to make a little change. In the original diagram here, I had the angles numbered improperly, so you might want to make that change on your notes. But angles 1 and 2 we can see are vertical angles. Let's prove that they have to be congruent. All right. So this is another example where I don't really have any given information. I just have a picture basically. So I'm not actually starting with given information in my proof because there's not really any information to start with. It's just a picture. What I am going to start by saying is that if I take 1 and 3 and add them together, I'm going to get 180. And the same thing if I add angles 2 and 3 together. I will get 180 from those. Well, how do I know that? Well, angles 1 and 3 combine to make a straight line, and so do angles 2 and 3. So that straight line here or right here, that's a 180 degree angle. It's a straight angle. But what's the reason that I know that angles 1 and 3 add up to 180 and that 2 and 3 add up to 180? It is the angle addition postulate. We've used that a few times now in proofs, the angle addition postulate. Now step 2 says, well, if angles 1 and 3 add up to 180 and angles 2 and 3 add up to 180, it means that angles 1 and 3 added together would be equal to angles 2 and 3 added together. And there's a couple of reasons you could use right here. You could use substitution. So you could say the substitution property. Or you could also say it's because of the transitive property. Because the transitive property is the one that says if two things equal the same thing, then they equal each other. So we could think about how the fact that 1 and 3 and 2 and 3 added together, they both equal the same thing. They both equal 180. So that means 1 and 3 added together has to equal 2 and 3 added together. Or I can think of the fact that 180 right here in this first equation could be replaced with angle 2 plus angle 3, because 180 is said to be equal to angle 2 plus angle 3. So either way, substitution or transitive property both would work as a reason for statement 2. Statement 3 says angle 3 equals angle 3, and that is, of course, the reflexive property. And like I told you in class, oftentimes when the reflexive property is used in a proof, it's because something is going to happen to the thing that's said to be equal to itself. And so if we look at statement 2, angle 3 is both on the left side right here, and it's on the right side right there. And if we take those out of the left side and right side, then what we're left with is that angle 1 has a measure that's equal to angle 2, which would mean that they are congruent to each other, which is what we're supposed to prove. So what happened? Well, we took the angle 3's and we subtracted them from both sides of statement 2, so that is the subtraction property. All right? And that left us with measure of angle 1 equals measure of 2, which we understand to mean the same thing as saying that they are congruent. So there you have it. We've just proved that vertical angles will always be congruent. And you definitely need to remember that. You'll use that a lot this year. All right, so the last thing left is this example here where I have 3 different lines crossing each other. Line AD, line BE, and line FC. They all intersect here at O. And I've given you the measure of angle AOF is 40, and the measure of angle BOC is 60. And I have a bunch of angles that I want to know either what they're congruent to or what their measures equal. So I just wanted to point out, I'm going to have you guys work this out, but I want to point out that these should not be numbers because we're not saying that their measures are equal to something. We're saying that what are they congruent to. So your answer should always be an angle. Angle something, angle something, angle something, and angle something. But down here, these we're saying that the measures are equal to some blank. That indicates that I want a number for those answers. So I'm going to have you guys try some of these, and we'll go over these answers in class. All right? Have a good one.